Hello everyone. So this is the very first video in the JavaScript playlist. And before I start with this video, I'm assuming that you have at least a basic knowledge of JavaScript. At least you know how to create variables or functions in JavaScript. And second point is the most of my references for this video have come from this awesome book YDKJS by Kyle Simpson. It's a very famous book for JavaScript. You can get it online on GitHub, and there should be a paperback also available, I guess, on Amazon. Having said that, let's get started with the video. So before we look into JavaScript engine, let's briefly understand what is compilation and what is interpretation. So compilation is a process of executing a program. In this process, we feed the compiler, which in itself is a program, and that compiler, that software, that program takes that code file and converts that into a machine readable instructions. But compiler reads the entire file at once and creates another file that would have the machine readable instructions that is fed to the computer later on. For example, you must have seen while executing C++ or C programs, once you run your C file or a C++ file, you will get .out file. That is essentially an executable file for the machine. Same thing might happen in Java as well. Now, coming to interpretation, uh, the basic methodology is the same, but the code text that is converted into machine readable instructions, but it happens line by line. So it doesn't process the entire file at once. It processes one line at a time. For example, maybe in a language like Python. Now, remember this concept. This will be used further as we look deep down into JavaScript. Now, you might have a question whether JavaScript is a compiled language or an interpreted language. So, I will leave that as a question for now. Maybe at the end of the video, your thoughts will become much more clear on that. Now, let's understand a bit what is a JavaScript engine. So, let's say you have a JS code here. So, you have some JS code file. So, I'm using the writing pad for the probably first or second time. So, please bear with me till I improve my handwriting with this writing pad. I think it will improve in the upcoming videos. But for now, let's manage. So, this JavaScript code is fed to some another software, to some another program. And what this program does is typically it understands what the JavaScript code is saying and finally gives us the result. Now, this result could be various things. Maybe it could be just a console.log or an alert or some DOM manipulation or anything, right? Now, this is a highly complicated process. I am discussing it here in a very simplistic manner. Now, this particular software, you might call it as an engine or you might call it as an JS engine. Now, where is this engine located? So, typically, it will be located in a browser, but you can isolate this engine as well and maybe set up a local as well. It's open source. In most of the cases, it's open source. And there have been many different engines that have been developed, but the most famous one that's used of late is V8. So it's developed by Google, and Chrome also uses V8 engine as its JavaScript engine. My handwriting with writing pad is terrible. I definitely need to improve. Anyways, let's keep moving here. So I hope you get the concept so far. So there is JS code that gets fed into a software called JavaScript Engine, and this JavaScript engine typically would be V8 engine, named as V8 engine. Uh, there are other engines as well, but typically, in most of the cases, it's V8 that is being used. Cool. Okay, so I hope your concepts so far are clear. This is what a JavaScript engine is, and let me create a new file. So now, as I mentioned, that this book is my main source of reference. So as per this book, it defines something called as a compiler theory. So this is essentially how a JavaScript engine might be executing a JavaScript program. So let's take a very simple example. Let's say a token where is equal to 5. So what this JavaScript engine will do is the very first step will be tokenization. So it will break down this var a equal to 5 into an array of tokens. So the first token would be var, another token would be a, another token would be equal to, another token would be 5. Now once we have this array, the second step would be parsing. And in parsing, uh, this token of arrays is taken and what is created is an AST. AST stands for abstract syntax tree. So as you might be familiar with data structures, it's a tree data structure. So what it might be doing is it will create a root here. Let's say var declaration, and on the childs it will have here, let's say a, and here it will be 5. And now the last process would be code generation. And code generation is typically taking this AST and converting that into machine readable instructions. And finally, that machine readable instructions are taken and executed by the computer. So this is a very, very high level of what a V8 might be doing. So we exactly might not be knowing what exactly V8 is doing. It might be a very, very complex program. There will be optimizations. There might be some kind of caching happening. But this is just a very overall, holistic, not a holistic, but a very high level vision what the V8 engine or any JavaScript engine might be doing. So let's move after this. Now, the big question whether JavaScript is an interpreted language or not. So, this is what Kyle Simpson also touches upon in this chapter. So, there are many sources online that say that JavaScript is an interpreted language. That means JavaScript is interpreted line by line. Now, the author, the Kyle Simpson, he argues in his chapter with an example. Let's say I have declared a variable called var a equal to 5. Then I'm logging this variable with console.log a. And then I'm declaring one more variable. And let's say I'm declaring it as high, but there's a syntax error. There's a dot here. So this is syntax error. Now, if we think that JavaScript is an interpreted language, then what should essentially happen? First, this code of line should be executed. Then it should actually output what a is. It should output 5, and then it should throw an error that there is a syntax error. So let's run and see what happens. So it doesn't print anything. Okay, it doesn't print anything. It throws an error straight away. So this is where the author argues that JavaScript might not be a completely interpreted language, and what the author describes it that the execution of JavaScript code will be happening in two phases. So let's create a new file. So what the author says is that JavaScript will be executed in the two phase. There will be phase one. Now in this phase, the V8 engine would be going through the entire program and checking for any syntax errors. And if there are any errors, then certainly it will throw error at the time of running the program. So typically, if we talk about purely compiled language, the errors will be thrown at the compilation stage itself. The executable file won't be formed. There will be a syntax error thrown right at the compilation stage. But here, JavaScript is not a purely compiled language, but we are saying that in phase one, there is something like a compilation that takes place. So, what author is saying that here is the JavaScript engine will just run through the code and check for some errors. And if there are errors, then certainly it already knows of them error ahead of time, ahead of executing the first line of code. And before the first line of code is actually executed, it knows that there's an error from the phase one and it will throw it. Now, if the phase one looks good, there is a phase two. Now, phase two is typically where your you may say interpretation or the JavaScript execution is happening. So let's say the phase one looks good. Okay, so there is some error here. Give me a minute. Oh, I'm sorry. This is a Java file. I need to have a JavaScript file. So let's run that previous example again. So var a equal to 5 console.log a, and then var p. Okay, so it's throwing an error because of phase one, that there's an unexpected token. That's a syntax error. Now let's say the phase one looks good. There is no error in the phase one. Then it will work completely fine. Cool. So one thing is clear that there seem to be two phases in which JavaScript engine runs this code. Uh, One is where it looks for syntax error and maybe some other kind of errors, and phase two is typically where it will execute it. Now there are different terminologies that are used for these phases. So, for example, the author Kyle Simpson, he mentions phase one as compilation phase and phase two as interpretation phase. But there are different terminologies for this. So some people also use creation and execution phase. So creation is the phase one and execution is the phase two. But no matter what terminology is used or what terminology you're comfortable with, we clearly understand that there are two phases in which JavaScript code is executed. And now, this is a very important concept and it kind of lies the foundation for the concepts ahead: scopes, closures, hoisting. I would also recommend you to go through this link, go through this chapter. I will put it in the YouTube video description. I have just covered a gist of it, but the author has written a very detailed description of the concept that we just discussed here in this chapter. I would highly recommend you go through this. And in the next video, I will cover a detailed version of what an execution context is, what scope is. Then we'll be discussing also about closures, hoisting, and after that we'll build on it and we will discuss more advanced JavaScript concepts. Meanwhile, do like, do share, please comment for any feedback. There might be few things off in this video, my handwriting tab pad. These will certainly improve with the coming videos, but my main aim is to communicate about the JavaScript concepts in a clear and a crisp manner. Hope you like the video. Subscribe and share, like, and also follow me on Twitter. Thank you. Thanks for watching.